Good afternoon, good morning, everyone. Happy hangover Halloween. Hopefully you didn't eat too much candy. I did not this time, so I'm pretty happy about that. Anyway, Todd Wenzel, Solutions Architect based out of Georgia. I am going to go ahead and share my screen here in a second. All right. All right, let me find the right window. Okay, I hope you can see this. Today, I want to talk about Megaport Cloud Router and how you can use that Megaport Cloud Router to simplify your cloud-to-cloud computing. So let me just go ahead and put this in present mode. It'll probably be better. Um, quick review. We want to go into a demo of the Megaport Cloud Router, excuse me, connecting AWS and Azure. But wanted to give you a high-level overview of Megaport. So Megaport is a network as a service provider. We were established in 2013 out of Brisbane, Australia. So we've been around about 11 years, and we own and operate our own global network as a service platform. So we're private layer 2 connectivity. Today we have 2,800 plus customers. You can see a list of who's who on there. And kind of what's unique about Megaport is that we build our infrastructure into over 100 unique data center providers. So it's not just a single data center provider where we have our rack and stack our gear. It's the Digital Realties and the Cyrus Ones and Equinix, and the list goes on and on. So customers that have infrastructure that sits within two different data centers or data center providers, they definitely have the ability to run data center interconnection on our network between those two sites. 360 plus service providers. So we have a very large ecosystem, which we call the Megaport Marketplace, that has SaaS, IaaS, PaaS, UCaaS, VoIP, you name it, providers in our marketplace that you have the ability to connect to fast and obviously very quickly through our private layer 2 network. And one of the unique value props about Megaport is that speed of deployment. So once you're ready to go, you can create an account within the Megaport portal within 10 or 15 minutes. And from that point, you can start building services. So you can connect your data center into the Megaport infrastructure, build connections to the major hyperscalers. Obviously, we've got connectivity to all of the major CSPs. And yeah, you can do that through a Megaport. We do have simple billing, flat rate pricing, depending upon the connectivity that you're trying to build out. And again, it's fast. You can do this within minutes. You can turn up a port in a minute or two, and within another minute, we generate an LOA for that data center for you in order to build that cross connect out to your data center router. And then you can start spinning up connections. Also, we do a lot with virtualization. So we're not just a data center single mode fiber cross connect into your platform. We also have a Megaport Cloud Router, which we'll talk about today, which is a virtual router that's hosted within our environment. No infrastructure needed by a customer. We're hosting that platform. No need for customers to maintain it. We do that. And then we also have a Megaport Virtual Edge, which is also a virtualization platform, really a compute. And we have a host of vendors that we host their images or their VMs directly on our Megaport Virtual Edge. And those two virtualization products are used to connect to the cloud as well. Next, we're going to talk about the MCR today. So the MCR, it's for cloud-to-cloud computing. We also call it cross-cloud. So again, the unique thing about this is if you're looking to migrate workloads from, say, AWS to Azure, you're looking for a low latency solution, a simple solution, a Megaport Cloud Router is a perfect fit. You can deploy a cloud router in, say, an Ashburn metro market and build a connection to AWS. If your workloads reside in Ashburn, Azure, same thing, virtual, so it's very quick to spin up. you would build your direct connect and your express route connections off of the MCR. And once those connections are established, BGP peering is really handled through automation. So once you connect your VPCs and your VNets into this environment, the MCR will just pass any IP prefix that's being advertised from one cloud to the other. So it's kind of magic. It's full-fledged automation. You can deploy it via the Megaport portal. You can deploy it via our public API or else via Terraform. Again, we see a lot of customers doing cloud-to-cloud migrations or customers that are moving out of their data center and everything is being hosted within the cloud. So they'll spin up an MCR just to handle those workloads. 4 different sizes: 1 gig, 2.5 gig, 5 gig, and 10 gig. Megaport's providing that layer 2 connectivity, so it's a VLAN based connection between the cloud router and say an AWS, and then the BGP just happens to ride on top of that. So we do offer some features. It is a GUI interface, so you do not have to know CLI commands in order to spin up this MCR. So we offer obviously BGP, MEDS, NAT, BFD. We can do prefix filtering, AS path prepend. And then last but not least, there's a looking glass feature within the Megaport portal, which will show you all of the IPs that are being propagated from your various cloud service providers or your data center. You may have a connection from your data center into the MCR. And last but not least, we've kind of talked to speed to provision. This really only takes a few minutes to spin this up. And Megaport offers VXC, so I mentioned VLAN earlier. So anytime you connect a port, an MCR, or an MVE to another endpoint, it's done via a virtual cross connect or a VLAN. So it's an 802.1q VLAN, and that's a private connectivity between 2 endpoints. So the BGP peering again rides on top of that, and we have adjustable bandwidth speeds anywhere between 10 meg and actually 100 gig. Each cloud service provider has different bandwidth offerings, so we obviously recognize what their size and speed is. And in some cases, you have the ability to dynamically scale those. AWS hosted connect, it's a static bandwidth. So if you wanted to spin up a connection from a 1 gig to a 5 gig, you would actually have to deploy a new connection at the higher bandwidth or lower bandwidth and then delete the old. With Azure, you have the ability to scale up but not scale down. And these are recs of the cloud service providers themselves. So that is a VXC high level. And last but not least, let's talk about what we're going to deploy within the portal today. So I plan to spin up a Megaport cloud router in Ashburn, like we see here. This just gives us, again, the bandwidth increments, VXC connection. So the VLANs, VXCs, you have the ability to spin up to 25 VLANs to a single MCR. So if you want a AWS VXC to US West and US East and Singapore, and you wanted to have individual connections dedicated for those that VPC connectivity, you can spin up 3 AWS connections, and you can do hosted connect and hosted VIF, and so you have a lot of flexibility in designing what you want. And again, if you design something that you only need for a month, it's very easy to delete that connection once you're done using it and build it in a different manner. We talked about the advanced features, so AS path prepend, BFD, MEDS, and route filtering. So we do have a lot of customers that do take advantage of our route filtering by building up to 50 prefix filter lists. And you have the options to add those filters on import and export per individual peer. So it's a very unique and easy way to really manage your traffic from a BGP perspective. So what we'll do here is we'll create the MCR first, and then we'll build an express route connection in the Microsoft portal. I'll show you how you get your key and apply that to the Megaport connection. And then we'll also build a connection to AWS. All right, so first and foremost, let's go into the Megaport portal. As you can see, we have 3 options here. We've got the port, the Megaport Cloud Router, and the Megaport Virtual Edge. Let's go ahead and click on the MCR. This is a list of all of the locations across the globe where we do deploy the Megaport Cloud Router. And one thing you'll notice here as well is diversity zone. So if we have it selected to auto, it will provide us through algorithm which diversity zone we'll deploy this MCR on, whether it's red or blue. What this really means is it's different servers. So if we're deploying HA pairing with MCRs ports or MVEs, and we definitely want to deploy on different diversity zones. We don't want a maintenance to impact two different devices or access components by having them on the same diversity zone. So I can leave it for auto, or I can select the diversity zone that I would like if I have something that I've already deployed. Let's go ahead and select auto, and let's grab Ashburn. 4 locations where we host the virtual router servers. So CoreSite, Equinix, NTT, and QTS. Let's go ahead and select CoreSite. Here are your rate limits. Again, 1, 2.5, 5, and 10. Each bandwidth size has a specific price for it. And you can see we have no minimum term, 12, 24, 36 a month. I'll give this a name. Next, MCR ASN. So this is a Megaport's default ASN, 133.937. You do have the ability to change that to a private or public ASN of your choosing. I'll leave it as the default. And I'll go ahead and select next. So we can see we are on the blue diversity zone. If I decided in the future I wanted to add a second MCR in the Ashburn Metro, I would want to make sure to deploy that on the red diversity zone. And typically I like to do that in a different data center. Excuse me, hit add MCR. Quick validation process. And we are deploying. So this is going to take 2 to 3 minutes for this MCR to spin up. Once it does, this icon here will turn to green and show us that the service is up. I'm going to hop on over to my Microsoft portal. I need to build out my express route. What I will do here is find my express route icon, create express route. All right, so I have to have an Azure subscription pre-built. I also need a resource group. And then this is kind of new. It's been about a month and a half or 2 months since Microsoft changed the look and feel of this. They give you different resiliency options. So maximum resiliency if you want to deploy 2 different express routes in 2 different regions. There is a high resiliency metro option. And this is only available in Amsterdam and Singapore, I believe, but it is rolling out over the globe as far as this metro offering. And then your basic standard offering, which means you will create an express route, get 2 connections, one for your primary and one for your secondary. And that's what I wanted to do today. I'll choose East US as my region. Call this Todd Demo. I want to make sure that I have provider selected because I want to use a partner of Microsoft in Megaport. Type in Megaport, maybe. Oh, sorry. Peering location. I have to do that first. So for Azure, there are 2 on-ramps. One is in Equinix, and one is in CoreSite. Equinix is considered to be Washington, D.C. CoreSite is considered to be US East 2, Washington, D.C. 2. So I chose US East, not US East 2. So what I want to do is I want to select Washington, D.C. as my peering location. And here is where I enter in provider, type in Megaport, and then the bandwidth. So it does default to 1 gig, which is important to know. If you want to start off with a lower bandwidth increment just to do some testing, you will definitely have to change it. I'm going to make that 50 meg. And then Azure has certain billing SKUs that do require some research to find out what kind of monthly payment plan you would like to arrange through Microsoft. So I'm leaving this at default, standard, and metered. One thing to note is if you start off on premium and you decided you wanted to go to standard, you will not be able to do that. You would have to actually create a new express route. Now, if I start off standard and I want to go to premium, I can do that without a problem. Select on review create. I don't want to create any tags. And create. So this will take a minute or so before this is deployed. And once it is, then once it's been deployed, we'll get a service key that we can use within the Megaport portal. Excuse me. While we're waiting on that, let's go ahead and go into my AWS account, copy my account number, and let's go ahead and build the AWS VXC. Two different connectivity types. So we have a legacy hosted VIF model, which does not support Transit Gateway. Maximum bandwidth is 5 gig. And then we have the hosted connect model, which does public, private, and transit VIF. So it does support a transit gateway, and it goes up to 10 gig. So if you're using a transit gateway today, you do need to use the hosted connection model. For this demonstration, I'm going to go ahead and just use a hosted VIF. These are all of the cloud on-ramp locations that Megaport has with AWS. So we are directly connected, have NNIs directly connected into AWS routers over our private infrastructure. So the list is long. Go to US. And for the Ashburn metro market, I have some options. So I can connect to Equinix DC4 in Ashburn. I can also connect to CoreSite, I believe it should be in here somewhere. There's another one in Equinix DC. Oh, here we go, CoreSite, I missed it. Let's go ahead and just select CoreSite. I will call this an AWS VXC. Use 50 meg for my rate limit. Again, we can see the price for no minimum term and 12, 24, 36 month. This is a pretty cool field right here, this new VXC state. So for some reason you are trying to test some failover scenarios between maybe two different AWS peers. You can go in here and shut down one of these VLANs, which of course would shut down your BGP as well. But it does give you the ability to kind of manage and test failover routing. Select next and hit next. So my AWS account number, I'm going to pop in here. We talked about the MCR ASN of 133937. That's what we want or that's what we provision for the MCR. So it's going to automatically show us that ASN there. And let me go to Direct Connect. I don't recall which ASN I will be using on the AWS side. I'm going to terminate this to a virtual private gateway directly. I'm not using a Direct Connect gateway today. So we will see what this is. I just think I just clicked on the wrong field, but maybe not. Nope. So got into my VPC, grab this ASN. Now, BGP auth key customer IP addresses, I can put my own information in here for the BGP peering, or I can let AWS auto assign. Since this is the Megaport cloud router and Megaport is handling that layer 3 or BGP traffic, I'll leave this blank and let AWS auto assign it. Validating the order. Let's order now. Let's go back into Microsoft so we can see now our deployment is complete. Go to resource. And quickly, again, location US East. Megaport, we can see the provider status is not provisioned. Peering location DC, 50 meg, service key. So this is what we want to grab. And next, we'll go to plus connection. And because we're adding another connection to a cloud, I want to select cloud here, the cloud tile. If I was building a connection between, say, an MCR and a port in the data center, I would do a private VXC. I do have the ability to add Megaport Internet to my MCR. And here is Marketplace, where we've mentioned our ecosystem, over 360 different suppliers or providers that you could potentially connect to. And then we also have a service key offering if there's a vendor, or if you have a customer that wants to connect to you, you're not in the marketplace, they're not in the marketplace, you could create a service key that would allow them to create a connection between their Megaport account and your Megaport account. Select Azure, and we'll paste in our service key. So this shows us the beauty of the API between Megaport and Azure in this case, or we're API enabled with all of the major cloud service providers. This shows us that the key is valid. And we see that there are two different connections. So ExpressRoute does offer a primary and a secondary router on the Microsoft side. Um, so best case scenario is to deploy both of those. In case there is a maintenance on one of the routers, you'll have a backup path. I'll go ahead and select my primary, and I'll only configure the primary today. Peering type. So again, this is off the Megaport Cloud Router. If I wanted to only do private peering, I would just leave the default. But if I wanted to do Microsoft peering as well, I could select this tile here. And what will happen is public IPs will be assigned out of the Megaport block to this peering type. All right, Azure EXC. Since we set the rate limit to 50 in the Microsoft portal, that automatically flows to Megaport. So that API call from Azure updated that bandwidth option. So again, just a few simple clicks and we can get all of this going. And we'll see where we are with the AWS connection. Let's go back over to my AWS portal. I will go to Direct Connect and virtual interfaces. So this is the AWS connection that I just created. I want to accept it. So I'll accept this connection. As I mentioned earlier, I'm provisioning this to a virtual private gateway. Here is my VGW. I will accept the interface. And what we have here are the peering IPs. So once everything has been provisioned, this IP should show up in the Megaport Clouder as the Your Router peer IP. This is the Amazon peer. This is my ASN for my MCR and my ASN for my virtual private gateway. And we can see the color is up. So the layer 2 VLAN has been established on the AWS side. BGP has not yet established. Take a few minutes probably through automation. Back in our Azure environment, let's do a quick refresh. See if we can get this to change from not provisioned to provisioned. And once it's provisioned, the IPs, since we're doing Azure private only, those peering IPs should show up here for primary and secondary subnet. So it looks like it's still working, which is fine. A few other things, the looking glass feature on the Megaport Cloud Router. So again, this shows us, this will show us what all of the IPs are that are propagating between AWS and Azure, and if there's a data center involved, it'll be a full list of those IPs. Before I get into that, if I wanted to build prefix filter lists like I mentioned before, I can select the MCR details. And right here, I see prefix filter lists. So this is where I can create a list and I could say AWS, import, add as many prefixes that I want to add to that prefix filter list. And once I've done that, I can save it and I have that filter list built. I can do up to 50 of these prefix filter lists. And once they've been established, excuse me, I can apply them at the individual peer level. So once again, I go to the gear or the sprocket icon for the individual peer and select next. And right here, I see edit. So this is where I can add a few other features to my configuration. I can go to advanced. If I wanted to set up some AS path prepend, I could add AS values here. I think 3 is the lowest number of, let's see. Okay, it looks like you can do from 0 to the maximum of 10 prepends. Okay, I was thinking it was 3, but I guess you can do less. If you wanted to add inbound, outbound meds, you can do so here, and then set BFD timers. Filters, this is where I can create, add a BGP peer filter or build my prefix filter list or add my filter list. So if I had a list created and I wanted to, for import, I wanted to not deny, I would just hit the drop down and choose the applicable list and add it there. And then I can obviously do the same thing on my export prefix filter. Let's close out of here. And let's see, looks like we're still thinking on the AWS and we're still deploying on Azure. Let me just do a quick refresh since I can be impatient. Okay, we're still thinking. Another thing when you're going to the MCR details or VXC details is where you can see logs for usage, etc. So I can just kind of click through here, and now here is my Azure peering IP. We can see the peering information here. If I wanted to shut down the BGP peer, again, if I was doing some testing, wanted to test failover, I could shut down the VXC, or I can simply shut down the BGP by selecting the shutdown. Next tab shows me again the subnets that I'm using for the primary and the secondary. If I did request Microsoft peering, those public IPs would show here. Logs. So we can see now that the VXC is up. Of course, no, not of course, because Azure was lagging behind, but now layer 2 has been established, and it looks like the BGP peer is up. So this is a good thing to look at. If you think traffic's bouncing or if you think traffic is down but you're not really sure where it's happening within the network, it's easy to log into the Megaport portal and take a quick status check. Usage, so this would give you a utilization for each individual line item once traffic is actually being passed on that path. So Azure is up, BGP peering is up, AWS looks like BGP is still down, which is okay. So once again, Looking Glass, I think this is the last thing that I want to cover, and I know we're about 3 minutes from being done. So this is my Azure BGP peer. This is my AWS. Right now, I don't have anything connected into my Express route's not connected into a VNet gateway or a VNet, so you will not see any prefixes being propagated from my Azure environment. Obviously, my AWS is not complete yet, so right now we're just seeing the individual peers that are connected right now. So I think again we're right about time. I hope this wasn't too fast. I had a lot of information to cover in 30 minutes, and hopefully I did a good job of explaining how the Megaport Cloud Router can help you in your cloud-to-cloud computing adventure. Are there any questions?
No questions.
Great. Thank you, Christina. Well, I hope that you guys all have a great weekend. And if you have any questions in the future, please reach out to us at Megaport. We would definitely be happy to talk and support any of your needs.